Greetings and welcome, friends. Today is a big day in which we find out that all triangles are special, not just 30, 60, 90, and 45, 45, 90 triangles. And one of the ways we're going to do this today is we're going to talk about what's called the tangent ratio. Actually, you don't roll the R, but I'm able to, so I just did it for fun. A trigonometric, what? Ratio, what? So trigonometric, that's like the measures of triangles, the study of triangles, right? Is a ratio of the lengths of two sides in a right triangle, okay? All right triangles with a given acute angle are similar by a similarity, right? So these two triangles, they are the similarist. And it says the following, right? So if these two triangles are similar, then I could write a proportion saying the following. Right, that, look at this, that this KL is to YZ as JL is to XZ, right? That there's going to be a scale factor between these two triangles as such. And it turns out that this, right, we can rewrite this as KL over JL, the ratio of short leg to long leg, is going to equal the ratio of short leg to long leg for both of those, and it's no longer representative of the scale factor, but now it's a ratio of, right, short leg to long leg. And that those are the same for all right triangles that have the same acute angle for one of those angles. And today we're going to talk about the tangent ratio, is a trigonometric ratio for acute angles that involves the lengths of the legs of a right triangle. Specifically, from the tangent ratio's perspective, let's see, I'll do purple here. So it's always from the perspective of the acute angle. Tangent is the ratio of the opposite leg to the adjacent leg. Opposite leg to adjacent leg from the acute angle's perspective. So notice from this acute angle's perspective, the opposite leg is this one, and the adjacent leg would be the one that is touching that acute angle. Question, comment? Well, okay, that's actually a cool point. If I want to do it from a different angle's perspective, all right, that's a good question. Here's an acute angle. Its opposite leg would be this one, and its adjacent leg would be that one. It will be a different ratio, but it will be somewhat complementary. Or the angles are complementary, and the ratios will be reciprocals of x's perspective. All right, but let me get into some before we get too far. So the tangent ratio for triangle Abaca is, right, with acute angle A, the tangent ratio of angle A is written as follows. And instead of writing out tangent, mathematicians as efficiently lazy people, we like to abbreviate things. So we'll call it tan instead of tangent, but you would still read that as tangent. But if you're doing your math on the street and you're like, hey, what's the tan of 30 degrees, friend? Right, everyone will know what you're talking about, and it's cool. Yeah, it's cool. So from angle A's perspective, right, the opposite leg is BC, the adjacent leg is CA or AC, the hypotenuse is blue, and the tangent of angle A will be, right, that length divided by that length, and is going to be some ratio that we'll be able to work with. And that ratio, although different for triangles of different acute angles, it's consistent for all triangles that have that same acute angle. So like if this is a 27-degree angle, tan of 27 is the same for any triangle, no matter what scale it's at, that the ratio of the opposite leg to the adjacent leg for a 27-degree acute angle right triangle is going to be the same. All right, so here we go. So this is actually exactly the question that student asked. We can actually write tangents from two different perspectives. So from angle S's perspective, all right, if I want to find the tangent of S, that's going to be opposite over adjacent. Who is opposite from S's perspective? What number? Opposite? Yep. All right, don't worry. It's going to be the 80. And the adjacent is 18, yeah. Now, it's adjacent leg, so I do want to point out that the hypotenuse is technically adjacent to both of those acute angles, right? But we will always be referring, for at least with tangent's sake, we're going to be referring to the legs. So opposite leg, adjacent leg. What? You're just like, this is wrong. I don't like this. Like morally or just like mathematically? Oh, you're looking at, does the Pythagorean theorem apply here? That's actually an interesting thought. You might be right. You should test it out for us. You got a calculator right behind you. So let's see. Tangent of R. Yeah. You should. You should call them on it if they're wrong. All right. But if you're wrong, then you're stopping doing it, right? Well, I don't. So let's see. The opposite from angle R's perspective is the 18. And the adjacent from angle R's perspective is the 80. So tan of R is 18 over 80, which is 9/40ths. So notice, just as these two angles are complementary to one another, right? They would add to 90 degrees. Their tangents are reciprocals of one another. Their tangents are reciprocals of one another. All right. This is where it gets awesome. Example 2. Let's put this to work. What good is it to know ratios? To find the length of a leg. Here we go. All right. Find the value of x. Notice this doesn't say anything about tangent. This doesn't say anything about ratios. You just have to know this. So from this angle's perspective, the 32 degree, although I could also find its complement and then work from that perspective if you wanted. Which is the opposite leg? 11 is the opposite, right? It's opposite. And which is the adjacent? Is x. So if I set up the tangent, I'm just going to say tan of 32 degrees is equal to 11 over x. How could I solve that for x? Now, tan of 32 just represents a number. That represents a ratio. So if I want to get x by itself, you could flip both sides. You could cross multiply if you want to write this over 1. Let's do that. Let's do the cross multiplication first. All right. So I'll do, that would be the same as x times tan of 32 is equal to 11. And tan 32 is just a number, okay? That's all it is. So how would I get it away from the x? It's currently being multiplied. Yeah, I'll divide both sides by tan of 32. I think we have some jets flying over. So x is exactly equal to 11 divided by tan of 32. And you guys all know the tan of 32. You know the ratio of a 32-degree acute angle in a right triangle of its opposite leg to its adjacent leg, because this triangle is just as special as a 30, 60, 90, right? No, you don't. You don't know that. But your calculator does. Ooh. Look at this beautiful calculator. Actually, in the reflection, you can see, like, oh, all sorts of cool stuff. Oh, that's my mic in the reflection. There's the document camera. All right, so, I'll keep it mysterious. So turn on a calculator. There's an on button. Grab a calculator nearby you. I've got some on my desk, some in the front of the room as well. And perhaps you've noticed some buttons that you have not used on your calculator for a very long time. Have you noticed? What, do you see a button that might be helpful for us? Oh, there's a tan button right there. What? And it says tan parentheses, because tangent expects an input. I put a tail on my t because otherwise my t might look like a plus sign accidentally. That's the only, yeah. So, yep. So tangent, and notice this here, my calculator says deg. What do you think deg means? Degree, okay? Make sure your calculator's in degree mode. Otherwise, when you enter 32, it's going to be confused. And watch this. If I hit tan of 32, I technically don't need to close parentheses, but I will. That is the ratio. Yeah. Actually, tell you what, if you happen to use your cell phone for math when you're doing homework, verify that you can get this on your cell phone as well. Some inputs, sometimes you have to do 32 and then hit tan. Yeah, so just make sure you figure out which sequence you have to enter it in on your calculator of choice. Yeah, if you yeah, you should be able to rotate your calculator into landscape mode, and then you 32 then tan. And make sure that your calculator is giving you the same ratio, because your calculator on your cell phone might not be in degree mode. It might be working in radians, which we'll talk about later. So guys, what this means is 0.625, we'll call it, is what I could plug in here. So x is approximately 11 divided by 6.25, and then I could actually just calculate that. But instead of doing that, tell you what, this is the way I would do it. I would have just preemptively done 11 divided by tan 32. And I get 17.604. All right, so just make sure you know how to plug it into your calculator. And when you get a value, if you plug it in the wrong way, or what if I did 11 times tan of 32 instead of 11 divided by it, I would have ended up with a number smaller than 11, and I would have been suspicious of that. Okay, so you should be able to kind of do like a gut check at the end of every problem and just be like, does that make sense? Because this side should be longer than that side, because 32 is going to be the smallest acute angle, and this angle is going to be bigger than it. And that means this side must be bigger than 11. All right, so if that ever happens, that's what you do. Let's take a look at a couple more like this. And these are awesome, guys. We're solving right triangles. So cool. So powerful. You guys got to promise me you only ever use this for good, though. Oh, yeah, yeah. You could use the tangent function if you're on a mortar team and you're arbitrarily shooting mortar shells into like a village. You could use it for that. So just be cool, guys. Be cool. Like if you were invading a castle and you created some sort of trebuchet and you wanted to figure out like how to hit the tower that you wanted and at the right spot, you would use the tangent function. Just be cool, guys. Be cool. Use math for good. Unless, I don't know, maybe you're overthrowing some horrible despot. I don't know. I don't know. I have no idea how mortar teams do, like, their math so fast. They probably have some table that helps them out. Well, I did do problem 3 with you right now. Let's do it. So from angle 61's perspective, 61 degrees, which one is the opposite leg? All right, 22. And the adjacent is x this time. Okay? So let's set this up. So tangent of 61 degrees is going to equal the opposite over the adjacent. And this time, let's just flip it. 1 over the tan of 61 is equal to x over 22. And then to solve for x, so yeah, so what I did was I reciprocated both sides there. If I imagine this being over 1. I'm just showing you like a variety of ways that you can do this math, and then you can kind of pick however you want to do it after. So I'm going to get x is equal exactly to 22 divided by the tan of 61. Or x is approximately, let's see, did I get rid of my calculator yet? No. So I'm going to plug this in. I already forgot my numbers. 22 divided by tan of 61. So 22 divided by the tan of 61. And tan of 61, that's actually close to 60. Maybe I would have been able to get a good estimate using some of the ratios of a 30, 60, 90 triangle. I ended up getting 12.95. I lied. 12.195. There we go. Well, we would have known that if this was 60 degrees, then I could have just divided 22 by the square root of 3 and gotten this. There. Solve that problem. There we go. So yeah, and also notice that 12 is less than 22, and I felt like that makes sense. Let's have you guys set up number 4. I did that once in 4th grade. My mom had me use a garbage can lid as the turtle shell that was green. And then I climbed up the flagpoles, like, not the flagpole, the, like, firefighter pole. What are those? Why can't I word myself right now? Right? But there was, like, a ladder and then, like, the slide down pole. And when I got to the top, my turtle shell got stuck between, like, these two sidebars. And I had to be like, guys, everyone, you're going to go back down the ladder. I can't fit through because of my turtle shell. And then I was all embarrassed. But then I did it again later, and I realized I could have just turned sideways to fit my turtle shell through, like, the narrow opening. So that was a story about the time I dressed up as Michelangelo using a garbage can lid. Pro tip. So let's see how you guys do on this. All right, so let's set up this ratio. So tan of 56 is equal to, what do you guys write this time? X over 13. Awesome. I was worried you guys were going to write 13 over x because our x has repeatedly been in the denominator so far. So to solve, this time I multiply both sides by 13. Right? And tan of 56 is just a number, okay? So don't be afraid of that. So x is equal to 13 times tan of 56 degrees. So x is approximately, let's see, I'll plug it in my calculator. Ooh, look at these hands, my tungsten carbide wedding ring. So I've got 13 times tan of 56. All right, getting some comments on my fingernails. Fingernails. That's what Patrick says to SpongeBob. 19.273. All right. So yeah, so this is cool. It gives us the power of finding missing sides of right triangles prior to Pythagorean theorem being able to be used, right? And now once I have two sides, I could then find the third side using good old Pythagoras, right? So are you guys feeling more powerful yet? Oh, yeah. Because Pythagoras wasn't always nice to his students. I don't know. Okay, so let's take a look at this one. From this angle's perspective, they said, hey, you happen to know a little fact about special right triangles. So they're like, what do you know about this, guys? Well, let's see, this is the long leg, right? I'll call that L or something, I don't know. And this is the short leg, S maybe. That does look like a 1 though, doesn't it? What do you guys know about the tan of 60? Well, yeah, L is going to be the square root of 3s, right? Square root of 3 times s. It's the square root of 3 times longer. So according to this, from this angle's perspective, tan of 60 should equal, right, the square root of 3 times s, or s times the square root of 3, over s, right? Opposite over adjacent. Those cancel out. This is claiming that tan of 60 should equal the square root of 3. And let's actually verify that on our calculators real quick. So if I just do tan 60 while in degree mode, I get 1.732 blah, 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 which notice is the same as the square root of 3. Same thing. So your calculator just has this information pre-programmed into it so you can remember it. It'll just give it to you, right? Let's see. Do I have like one real life problem or something? Oh yeah, let's do this tree problem and then we'll call it. Here we go. It says you're measuring the height of a spruce tree. Okay, so notice it's kind of hard to measure the height of something by like climbing up it and then dropping down like a measuring tape. So instead, you measure your distance from the base. That's something that I can measure, okay. We're assuming the tree is growing perpendicular to the ground at this point. And then if you can calculate that angle, right? The height of my tree is the opposite from that angle's perspective. The adjacent from that angle's perspective is the 45. What's my equation? Right? This isn't scary, right? We're doing trigonometry. Behold the power of trigonometry. Multiply both sides by 45. And this is going to make this number bigger, I hope, because the leg opposite the 59 degree angle should be the bigger one. So h is exactly 45 times tan of 59. Or h is approximately 45 times the tan of 59. I should just like live stream, like people in chat would give me like numbers to punch into my calculator and then I'd do it for them. Like that would be a great live stream. No, come on, like instead of like having your own calculator, you just like go onto my chat channel and you hope your problem gets selected. And then like, oh, thanks, user number 72. Like, here we go, let me enter your problem. There you go. Like, that'd be the best live stream. 74.893. And this is measured in feet. Yeah. So look at that. We just calculated the height of a tree using trigonometric ratios that are conveniently stored into the memory of our calculator. All right. Thanks for watching, internet friends. Bye.